For the second part of this video series, I wanted to touch on some of the things that I didn't talk about in the first one, and let's start with some basics with channel referencing. And let's say with this simple setup, we have a box and we need to color it. One thing to remember, that's actually the single lines with VEX we can actually write inside any of the channels usually, where there's anything that's something like float or number or anything. So you see, it's basically asks you for the float number. What you can do is just delete this and start writing. You know that we have a random command, and the random all you can do is just to give it a seed like that, and that's it. Couple of things to know that you do not have to write a semicolon at the end, and you can actually see the actual value that be randomized by pressing on, going to the expression and toggle expression. For me, it's a hotkey Alt Q, so I can always see what it is. Of course, if you want to randomize, we also want to maybe create a channel that we actually can control and randomize. For that, we can actually go to the edit parameter interfaces, and there is basically every possible thing that you can change inside this node, and usually they are locked. But for us to add, we don't have to do anything. We can just go in this list, and you can see that's a float value. We can just drag it inside here. Now for the label, let's say randomize is basically going to be the randomizer. That's big, actually. Let's present it. Randomize is basically label is then display name that's going to be. Because you take a look at these ranges, there's range, and the name of it is different that we reference inside our red channel. So, and for what we want to, and for us to reference, you want to rand. You're gonna reference rand. Apply, accept. Now if you take a look, we can basically place Alt Q again, and then we call it rand like that. One thing to know, you cannot actually write the GF. It's not going to work. So basically, when we created a Wrangle node, we basically said what kind of type we want, integer or float or whatever. But in here, it's just channel, because it's already know what kind of type it is, because we created the float value. Of course, nothing stops us from actually making the integer. Let's call it rand2 and randomizer2 like that. Apply. Now we can reference randomizer2. It's still going to work. One cool thing again is that you can actually change the value of it like that, the range of it. So let's say for our randomizer we want actually 100 numbers. So let's press 100, apply, you see our selector is now a much bigger one. So that's one cool thing though. How can we just single lines of VEX inside pretty much any of the sub nodes, or any node really, as long as it gives the expected number. That's really the main takeaway, that as long as the VEX expression that you write in gives the actual value data type that it expects, is going to work. One last thing I wanted to mention, that to finish up these single expression lines, that we can actually reference other channels other than the local ones that we created with the parameter interface. Let's say we create another box, and in the box there's a uniform scaler. Basically, we won't use this box, it's not even connected, but there is a float channel selector, and we can change the values. We can actually reference this uniform scale inside our randomizer color randomizer. You see, its parameter name is scale. So all you will do is delete the rand channel, and all you will do is just write also in quotes, still in quotes, dot slash, and now it's going to show everything that's inside this GO3 and box 2, and now it's going to give all of the parameters that we can select. And we know that we wanted to uniform scale. It's called scale. And now if we change the uniform scale inside our box, you see it changes the color. Also, you can actually, when you actually drag around other channels, you can see the relative channel reference is going to be the channel that we wrote before, and the absolute is going to be the full length of the path where it's actually located. So It's kind of a key to remember the absolute channel reference whenever there's actually lots of uses for it, to remember how it's actually called absolute channel reference when you give it the full path of it. Of course, we can also dot is basically just saying go outside this node and S, and we are now in GO3. But of course, we can just write an absolute reference, which is basically just, so you go to obj target slash obj, then with GO3, then with box2, and with scale, like that. Now you have absolute channel reference. Now let's shift gears and let's go to the help page and go to the geometry attributes. There's actually very interesting and important information here. I want to go to the here, and there's information about indexing and limit value variables. So you can see that basically calls all of the lm_num, and what we use to identify every point separately as the pseudo attributes, because in a wrangle node we actually write at lm_num or pt_num. So if you remember, we put down a wrangle node. Let's say we create a new int value that's going to be attribute. So like that. You can see it's actually we are addressing them as an attribute at pt_num, but actually we have not defined what's the value it, because it's already has a value. The value is the point number. So if you go here and press and display points numbers, you can see basically it already has a value and it's already predefined. And now if you take a look at the bottom, there's a common attributes for geometry, and we're gonna look at some of these like a scale and p-scale, but for now I want to pay attention to the n vector, which is normal direction, and that we can override the attribute to change the normal. So if you take a look at our geometry, there's an extra option for display normals. You can see that these normals are like a divided so that shading is correct. But if we, let's say, create attribute wrangle, and we know, let's leave this one. Also, sorry for the crop previously, I just noticed it, so now it should be fixed. So let's say we know that the n is one of the predefined, and we already know what kind of type this is. The attribute wrangle node is going to know that it's actually a vector type, so we don't have to type the data type of it. So let's just say at n, and let's make it to the, since it's a vector, let's just 1, 0, and 1. Let's close it down. Let's take a look. Now you can see in place of the 3 arrows that we had for the shading, now there's only one for each one of the points, and it points at the same direction because we have created, because all of these values are the same. So for us to actually randomize it, what we can do is just create a set of the curly brackets, and now we can actually use the rand function. So rand, let's randomize it with the channel, the same thing that we have done. Let's make it a test like that, and now let's just copy it at the rand. That's incorrect rand. So now let's just copy this to the 3 positions like that. Now let's press on creating channel. You can see we are now randomizing, but of course you can see that these normals are all the same because we are randomizing with the same channel with all the 3, and rand is going to give the same number out with the same point, with the same randomization float, because it actually doesn't matter how many times we have this in here, it's going to give the same number out. So that it does mean that we have 3 references to this channel, it's going to give the same number because its randomization is the same. So for us to change it, what you can do is just let's multiply but at pt_num like that. See already we have changes. We'll do the same with this one. So now we are introducing something unique for every point, which is its point number. Now the same with here. Now you can see we have different values for each point, but you can see that actually the X, Y, and Z is the same for each one of these because we are randomizing the same channel. So what you have to do is create something different for each one of these references to X, Y, and Z. So what you can do is let's just multiply by 10 and also in here by 10, by 100. Now we're getting a true randomization of the normals. Because now we have different values for all three of these channels like that. You see, it's actually kind of a slowing to that position because we actually do not have a actual you see it's kind of going in the same direction because the values are always going to be the from 0 to 1. Actually, if we disable do this with slashes and let's say you want to actually see the normal values right now, what we can do is we can declare, it's called declaring. So we are basically not going any value to it, we're just declaring n value, normal value. And you see, basically going to give us the normal values that are right now for this object. You can see it's basically going between the 1 and -1. So what we can do is actually change the range for this randomization between 1 and -1. For us to move this value to the -1 and 1, all we have to do is wrap this whole set function inside the fit function. Take a look at the help, it's pretty straightforward. It's basically gonna fit the value from one range to another. So we know right now our value is from what we generate for our normals is from 0 to 1. So let's put this whole thing inside the fit. Don't forget the brackets at both sides, so now we don't get any errors. And so let's think about it. So first it's gonna ask you for the number that we're gonna give it. So for us it's a vector, so basically this whole set is going to be our vector. And we basically all we have to do is after the brackets ends, after two brackets, then we have to give the range that we have now. So for us the minimal is 0 and now 1, and for the new one it's going to be negative. Negative one is going to be new min, and positive one is going to be the new max, and that's all. So now we have basically truly randomized this, our normals between -1 and 1. You can see at these values they all are randomized. Another thing what I wanted to show is that actually if you go down and write expression, attribute expression is basically just a single line of code that you can do and change the attributes for geometry, which is basically simple attribute wrangle node, simpler. So what I'm gonna do is actually put down that's a wrong one. Sphere. Let's create it like that. Let's put it inside here. As you can see, it's actually already pre-selection what we want to change. Let's say you want to change normals like that, and you can see that actually there's option for the self. So basically, it's going to already add the values that already has for the normals itself. And actually, let's say self plus 1. You can see it's basically going to add to every channel 1. But if you add plus value, it's not a value. See, we have now this constant value adding option. You see, we can actually individual channel change the normal way, normal direction like that. So now let's make it like that normals point to the top. Now we can actually do the same thing in the aside attribute wrangle. So what we can do is go to attribute wrangle and say add n dot, so we went to y channel, like n dot y equals add n dot y plus 1. Then close it off. We have basically created the same effect. Basically now it's 2 because it wasn't 1. You see it's exactly the same. But if you want to even faster move it, we can actually can't write even n dot y. All we have to do is just plus equals plus 1. So basically it's saying its own value plus 1. So we now have to write n.y again. So that's a cool trick. There's also the same with subtract and all that. So that's pretty common programming thing. Now I want to pay your attention to the very cool node, which is called attribute randomize. Attribute randomize. Which basically, the rule of thumb is if you can do it with the nodes, better do it with the nodes than with attribute wrangle. So this is very simple example to do it, and we can always randomize with attribute randomizer. So take a look at this. All it asks is attribute name, so we know let's say we want to n, like that. So we know that dimension is gonna be vector, so we want to 3, and there's very useful, so minimal value, so let's say -1, and let's copy it to all of these, like that. And this doesn't really change anything because it's not 4-dimensional, it's 3, so basically this one doesn't really do anything right now. So in options, there's an option for the global seed. So if you think about it, we have done exactly the same thing as we did with the attribute wrangle node, only a lot easier and faster, because basically randomizes. There's already built-in function for randomization, it's a randomize node. So that's one of the things to notice, that if you can do it with the nodes, do it with nodes. So why did I want to show the normals? So one thing that you do a lot when maybe creating some sort of environment is copying. So, and for that, in Houdini there's a copy to points. Let's say we have this box with the default normals, and let's just copy. We're gonna copy this sphere to this. Let's keep it like that. Let's turn off the points like that. Also, maybe not. Let's just create the box. Let's copy the box so that we actually can see the difference. You see, it's pretty obvious that it's basically gonna copy to the normal direction, because when we create normal, basically it averages all of these to the normal direction averages, like that. And let's say we have these normals inside here, these randomized normals. So this is going to be our geometry that we're going to copy to. Now let's scale it back in sphere box a little bit more, like that. You can see it's basically just copied to the direction of the normals, like that. And if we go randomize this global seed, you can see the copying on that is actually randomized based on its normals. We're gonna come back to the copying to points a little bit later in this video, but for now I want to delete this, and let's create another example for the VEX. So another function that's very useful. So what I'm going to do is create a curve, something like this. Now it's gonna resample it. So let's say how many you want, something like this. Let's say you want to create, we're going to copy some kind of poles on it with randomized objects and also randomized orientation. So like it's like maybe a little slanted, all of them. So what we can do it. So in a VEX, we want to maybe not perfectly create all of these at the same distance between the poles. So what we can do is attribute wrangle node. In a wrangle node, let's start with giving color to our curve. So at CD equals, so let's just give it 0, 0, and 0. Now we have a black curve. Now what we want to do is create a random, we can do is give us a random float value for each one of the points. So that, let's just create a we call it randomize, and then we want to multiply by at ptnum, like that. So now that we have set up our randomizer, all we have to do is create an if statement. So it's pretty simple. We're not going to talk about specifics of it, just how can you write this very simple if statement. I'm sure there is a lot more in-depth tutorials about if statements and all of that inside VEX. So all we do is if in brackets. So if, so we want to add random. We want to basically create if statement is if something happens, if our random is bigger than 0.5. After the brackets, we want to add cd and want to color the X channel gonna be equal 1. So now our channel is 0, 0, but if our randomizer on point is bigger than 0.5, it's going to be red. It's gonna basically inside the red channel going to be 1. So that's basically all we need, and we can close it down with the semicolon, and that's it. So take a look at this. See, we're randomizing our points, but of course it's because it's 0.5. The possibility of it is basically going to be very equal. So basically half of these points are going to be removed. For us to control how much of the points are colored red, what we can do is just instead of static 0.5, we can actually create the float channel. So let's create a channel. Let's call it how much, like that. Let's make it, and like that you can see we are now controlling how much we are actually going to remove the point that we want. So see, we can randomize and how much of a bigger channel has to be red. Now let's add some of the copy to points. So what I'm going to do is copy to points. Now what I'm going to do is tell record the channel points to copy to, and now just click the box. Let's make it a little bit bigger. Something like this. It's like a wooden board. Now we're gonna copy it to here. You can see that after the copying we have also inherited the point colors. So what you can actually do is in this copy to point there's actually option for the what kind of attributes it inherits. You can see if you have watched my group syntax video, it basically says inherit all the attributes except for these ones. So this alpha, p scale, and all that. So all we have to do is also add except for the CD. So add caret and CD. You see the color automatically disappears. For us to remove this point, there's a couple of ways we can do. Now let's do it with the probably the most easiest ways. Let's say we want to remove the red points. What you can do is, let's say you select these and press on delete. It's actually going to create a blast node. So let's just delete this group, make sure it's on point, add cd.x equals 1. So this is our group that's going to be blasted. Or we can even reverse the group. So you can see that all the points that are red getting blasted. And of course if we select go back to attribute, you can kind of control it. If you take what's you're being copying, go to attributes, you can actually change the randomization and also how many boards do we have. With this setup, it's kind of a roundabout way that we delete these points. What we can do is actually do it inside the wrangle node. So let's delete this blast node, and what we can do is use the function remove points. So if you go to the help, it's basically gonna remove the points from the geometry. So just take a look at this. It's basically for this if statement, we are not going to just color it, but we're gonna right there without coloring, we're just going to delete these points. So if you take a look at the syntax, it's pretty easy. We see geo handle and point number. So we all have to do is so we want to remove point, and then in brackets, so geo handle is 0 because we have connected it to the attribute wrangle node, and then add ptnum, like that. Close it down, and you can see we are now automatically deleting the points that are bigger than this value that we have in how much, like that. Now that we have our basic setup, let's say we want these wooden boards actually be different sizes. Let's try that first. So what you can do is attribute random. Let's go back to our Houdini help, and there's actually a couple of these geometry attributes that we can use. The first one I would say is the p scale, which is basically going to give each one of the arrow points our p scale attribute, and once we're gonna copy them, our box is gonna be different sizes. So it is kinda different than you would naturally think, that we actually are giving these geometry attributes to the point that we are copying to. And with copy to points, it's actually going to pick up this attribute and scale differently our wooden board. So let's go to attribute and let's just write at p scale equals, and now let's just randomize it. Actually, I'm going to turn off this one so you can see what I'm doing. Just randomize it again. My scale, let's call it like that. Actually, I forgot the channel, so my scale, then don't forget to multiply by at ptnum, like that. Add this channel. Actually, I had this one too, but this one has to be deleted, so out there. So actually, I'm going to delete channel that we do not use, like that. So now I'm going to turn off this one. You can see with this we have created our p scale for our geometry. If we change our randomization seed, basically gonna give our wooden boards a scale between 0 and 1. But it's not very practical usage for it. So what you can do is actually delete this and use our attribute randomization node. So in here you can just write in pt scale. Actually, ps scale I'm gonna copy like here, and we know that it is just a float number. So for dimensions you can go back to the one. You can take a look at this, and for randomization, what's great about this that we can set min and max values. So we do not want very small boards. So the minimum value maybe 0.8, like that. And now we're getting different sizes of boards randomized. And of course with seed we can actually change them. So that's very useful. But of course it doesn't really has to be the p scale. We can basically any of the attributes that we want, we can randomize in here. And for one last thing for this video, I wanted to add, let's say we have our randomized sizes of it. Let's say we want to also randomize its orientation. So let's just put down another attribute. I will randomize it. I'm just going to duplicate it. And now, if you take a look at the help, there's actually a couple of, there's orient, which is basically going to randomize our orientation of this object. There's also rot, so let's start with orient. Let's take a look how it works. So from the help we can see that it's a vector 4, so for the dimensions we have to put it at 4. You can see it's already working. So we are now randomizing our wooden beams. So for the values of it, it's kinda, if you put everything at 0, you're gonna get the default position for all of them, like that. So this is basically what we copied before. So, and with that we can just start adding values. So I would say just start with very little, because right now you can see it's already going too much. So just add a little bit. So I would suggest you to, you see that for the if you go to positive, it goes to the one direction, if negative, to the other one. So, but the good, kind of a good between. So I would suggest to add equal amount of to negative and plus. So -9 and +9, like that. So you can see that these beams are actually going to the both directions. Now let's just do that same to all of the rest of them, like that. You can now see. Now we are randomizing our orientation. Something like this. Like that. So now here randomized our duplicated geometry. And also I wanted to, for the next video, it's gonna be also, I'm still gonna make these VEX videos, but for the next video I'm going to show how can we copy to points multiple objects, and how can we control the amount of objects that we copy. So let's say we want a box and also the sphere and some other, like a tube. How can we control how much we want to copy boxes or spheres, and the influence of copying, so that we have one object more than the other one. So that's it for this tutorial. I hope you found something useful in it, and see you next time.